Hi guys, welcome to my channel. In this video, I will be covering complete unit 1 in DAA subject. I will explain all these topics in detail. If you are watching this video for the first time, don't forget to like, share and subscribe to my channel. Guys, I have uploaded complete DAA subject tutorials. I will provide link in description. You can watch from there. Let's get started. At first, I will explain what is an algorithm and what are the characteristics of an algorithm. Algorithm is a step-by-step procedure to complete a task is known as algorithm. It is not like you are using algorithms only in computers. You are also using algorithms in your real life. For example, I want to make coffee. What I do is, at first in step 1, I will take a pan and I will add milk in it. After that in step 2, I will switch on the gas stove, and in step 3, I will add sugar and coffee powder. In step 4, I will boil it, and at last in step 5, my task gets completed, that is, my coffee is ready. Here my task is to make coffee, so I followed sequence of steps in order to make coffee. This is known as algorithm. An algorithm is step-by-step procedure for solving problem or to complete a task is known as algorithm. Next, you need to know what is meaning of pseudocode. Pseudocode is an informal and artificial language that helps programmers to develop an algorithm. Informal means user-friendly language. Artificial language means man-made language. Language which is created by human beings is known as artificial language. So, algorithm which is written in English-like language is known as pseudocode. Whatever the algorithm that we are writing in English-like language is known as pseudocode. There is no proper rule to be followed in order to write an algorithm. So, you can write algorithm as your wish. This is an example. Here I am writing algorithm for addition of two numbers. Step 1. Always step 1 is start because I am starting algorithm. And in step 2, I am reading two values. After reading two values, in step 3, I need to add these two values. After adding two values, in step 4, I need to store this result in another variable. And at last in step 5, I need to print variable that contains result. And at last step 6 is stop. This is how we need to write algorithm. There is no proper rule that we need to follow in order to write an algorithm. So you can also write this same algorithm like this. Step 1 is start, and in step 2 I am reading two values, that is A and B. After reading two values A, B, I need to add these two values and I need to store this result in another variable C, and I need to print this C because it contains result, and at last step 6 is stop. This is how we need to write algorithm. There is no rule that you need to write algorithm only like this. You can write algorithm as you wish. Here I written same algorithm like this. Here this is another example. Here I am writing algorithm for average of three numbers. Step 1 is start, and in step 2 I am reading three values. I am assuming values as A, B and C, and step 3 is sum A, B, C. That means I am adding A, B, C values. After adding, in step 4, divide sum by 3, and in step 5 I am storing result in another variable, that is variable D. I am storing this result in variable D, and in step 6 I am printing variable D because variable D contains result. So I am printing variable D in step 6, and in step 7 stop. Now, or you can also write end program. This is how we need to write algorithms. These are the properties which we need to follow before writing an algorithm. These are the characteristics. You can also say this as characteristics of algorithm. First one is input and output, and second one is finiteness, third one is definiteness. You can also say definiteness as unambiguous, fourth one is effectiveness, and at last fifth one is generality. First one is input and output. Each algorithm must take 0, 1 or more quantities as input and should produce at least one output. For example, in this example, algorithm took two quantities as input. An algorithm must take 0, 1 or more quantities. So, input can also be 0. For example, here I am not writing any input. For example, start. Next, directly I am printing C. Print C and stop. In this I did not take any input. So, here quantity of input is 0. An algorithm must take 0 or 1 or more quantities as input. Input can be 0, that means there is no need of giving input, but there must be at least one output. An algorithm should produce at least one output. This is first property. And second property is an algorithm should terminate in finite number of steps. That means we need to complete algorithm in countable number of steps. There should not be any infinite steps in algorithm. For example, if you see this example, in this algorithm was terminated in 6 steps which are countable 1, 2, 3, 4, 5, 6. So always algorithm must terminate in finite number of steps and there should not be infinite number of steps in algorithm. Third point is definiteness. You can also say definiteness as unambiguous. Each step of an algorithm must be clear, means no ambiguity. Means whatever the steps that we are writing in an algorithm, each and every steps must be clearly understandable. There should not be any ambiguity. Ambiguity means mistake. There should not be any mistake. This is known as definiteness. For example, in previous example, I written read a comma b. This step is clear because I am reading two values a, b. But if I written here only read, then it will become ambiguous because what should I read? Should I read a or which variable? So it will become ambiguous. Step 4, effectiveness. Effectiveness means algorithm should contain only necessary steps. It should not contain any unnecessary steps. This is known as effectiveness. And at last, fifth one is generality. Whatever the input that we are giving to algorithm, an algorithm should work with our input. This is known as generality. Algorithm should run for any type of input or data. These are the 5 properties or characteristics of algorithm. Next topic is performance analysis of an algorithm, and also I will explain what is time complexity and what is space complexity. Let's get started. An algorithm is said to be efficient and fast if it takes less time to execute and consumes less memory space. Performance of an algorithm is said to be good only if it takes less time to execute and consumes less memory space. So in order to analyze performance of an algorithm, we use time complexity and as well as space complexity. That is, performance of an algorithm depends upon time and as well as space. At first I will explain what is time complexity. The time that an algorithm requires for its execution is known as time complexity. The amount of time that an algorithm requires for its execution is known as time complexity. There are 3 types of time complexities. First one is best case time complexity, second one is worst case time complexity, and third one is average case time complexity. If an algorithm get executed in short period of time, then it is known as best case time complexity. If an algorithm requires minimum amount of time for its execution, then it is known as best case time complexity. And if an algorithm requires maximum amount of time, that is if algorithm takes more time for its execution, then it is known as worst case time complexity. And third one is average case time complexity. If an algorithm requires average amount of time for its execution, then it is known as average case time complexity. I will explain best case, worst case and average case time complexities with an example, that is with linear search example. We know what is linear search. Linear search is the process of searching elements one by one until we found key element. In linear search, we will search each and element one by one in order wise until we get our required element, is known as linear search. Here I took example. There are 5 elements, that is 10, 20, 30, 40 and 50. In this I want to find element, that is element number 10. So we will start from first. Here first element is 10. So we got our required element at first. So it is known as best case time complexity. And another example, this is same example. Here I want to find element number 30. We will start searching from first. 30 is not found at first position, so then we will move for second position. Element is 30 element is not present in second position, so again we will move this element one step forward, that is 30. We got our element 30 in third position. It does not took minimum amount of time and it does not took maximum amount of time, so it is known as average case time complexity. And here third example, here I want to find element number 50. At first we will start with first element, that is 10. 50 is not present at first position, so we will move one step forward. 50 is not in second position, again we will move one step forward. In third position element is not found, and in fourth position element is not found. We got element 50 in last position, so time consuming is more. It is known as worst case time complexity, because it took maximum amount of time, whereas in first it took minimum amount of time, so it is known as best case, and whereas last one is worst case time complexity. This is an example of time complexity. In order to calculate time complexity, we use two approaches. First one is frequency count. We also call this frequency count as step count, and second one is asymptotic notations. Now I will explain components of time complexity. There are two components of time complexity. First one is capacity of system, and second one is computer containing single processor or multiple processors. I will explain first one, that is capacity of system. Capacity of system depends upon various factors such as RAM, processor, and type of windows that we are using in system, so on. So if speed of computer is fast, then output will be generated fastly, but if speed of computer is slow, then output will get generated slowly. This is known as capacity of system. Second one is computer containing single processor or multiple processors. If computer contain only one processor, that is only single processor, then output is generated slowly, but whereas if computer contains multiple processors, then output is generated fastly. These are the two components of time complexity. Next topic is space complexity. Space complexity is same as time complexity, only difference is that in place of time we need to write space. So definition of the space complexity is amount of space that an algorithm requires for its execution is known as space complexity. Same as time complexity, space complexity is also classified into three types. First one is best case space complexity, second one is average case space complexity, and third one is worst case space complexity. If an algorithm requires less space, that is minimum amount of space for its execution, then it is known as best case space complexity. And if an algorithm requires average amount of space for its execution, then it is known as average case space complexity. And if an algorithm requires more space, that is, and if an algorithm requires maximum amount of space for its execution, then it is known as worst case space complexity. Now I will explain components of space complexity. Basically there are three components of space complexity. First one is instruction space, second one is environmental stack, and third one is data space. First I will explain instruction space. The amount of space that is required in computer in order to store instruction, that is space required to store instruction, is known as instruction space. Second one is environmental stack. The amount of space required in order to store partially executed functions is known as environmental stack. And third one is data space. Space required in order to store variables and constants is known as data space. We can calculate space complexity of an algorithm by using two parts. First one is fixed part and second one is variable part. In fixed part, variables that have independent characteristics, that mean variables which do not depend on another variables, is known as independent characteristics of variable. So in fixed part, variables that have independent characteristics, for example constants, and whereas in variable part, variables that have dependent characteristics. Dependent characteristics mean variables which depend on another variable, whereas in fixed part, variable do not depend on another variable. This is formula in order to calculate space complexity. Space complexity of an program, that is S of p equal to C plus SP, C, where C is constant. We can also call this C as fixed part, and whereas SP is variable part. These are the examples in order to calculate space complexity of an algorithm. This is an example of algorithm, that is ABC of x comma y comma z. Written x into y into z plus x minus y. This is an algorithm. Here we need to calculate space complexity. At first we need to find constants, size of constants, and after that we need to find size of variable space. At first I am finding what are the constants. For example, each constant occupies 1 unit of memory. How many constants are there? 1, that is x, y, z. X, y, z. Total there are 3 constants. So, it occupies 3 units of memory plus variable space. There are no dependent variables. Dependent variables are not present in this. So, 0, that is 3. S of p, that is space complexity of this algorithm is 3. Similarly, second example, int square of int a, where a is constant. At first I need to calculate what are the constants that are present in this program. Only a, there is only single constant, that is a. So here size is 1 unit. It occupies only 1 unit of memory because there is only one independent variable. So 1 plus dependent variables. Here in these dependent variables are not present. So 0. Space complexity of this program is 1. S of p is 1 because there is only single independent variable, that is a, and it occupies 1 unit of memory. Similarly, another example, sum of x comma n, total equal to 0. This is an algorithm. Here sum is x comma n and total equal to 0. For I 1 to n, do total equal to total plus x of I. This is an algorithm. At first we need to find independent variables, that is constants. Here total there are x, n and total. Total there are 3 constants. First one is x and next one is n and third one is total, that is 3. Total occupies 3 units of memory. In this dependent variable is present, that is I. I is dependent variable. Size of I is 1 to n. So we should consider size as highest element, that is n. For example, here size is 1 to 5, then we need to consider size as 5 because we need to take only highest element as its size. So here size is x of I value is 1 to n, that is n. We need to consider n, that is n. Here space complexity of this program is 3 plus n. For example, here I took size is 5, that is 1 to 5, then here value of I is 5. For example, I took 15, then here value is 15, that is 15 plus 3, that is 18. This is how we calculate space complexity of an program. Space complexity of a program is calculated by using fixed part and as well as variable part. Fixed part is nothing but independent variables, that is constants, and whereas variable part contains dependent variables. In this example, there are total 3 independent variables, that is x, n and total, and dependent variable is I, and each element occupies 1 unit of memory. Next topic is asymptotic notations. By using asymptotic notations, we can calculate time complexity of an algorithm. Time complexity means amount of time taken in order to execute an algorithm is known as time complexity. By using asymptotic notation, we can calculate best case time complexity, average case time complexity and worst case time complexity of an algorithm. I already explained what is best case, average case and worst case in previous example, that is in linear search example. If we found an element in first position, then time taken is less, so it is known as best case time complexity. And if element is found in last position, if we found element in last position, then time taken is more, so it is known as worst case time complexity. And if element is found in between first and last element, then it is known as average case time complexity. Asymptotic notations are classified into 5 types. First one is big O notation. It is denoted by capital O symbol. Second one is big omega notation. Third one is theta notation. Fourth one is little o notation, and at last fifth one is omega notation. I will explain each and every notations in detail. First one is big O notation. It is denoted by capital O symbol. Big O notation is mainly used to represent upper bound of an algorithm's runtime. It is mainly used to represent upper bound of an algorithm. And by using big O notation, we can calculate worst case time complexity of an algorithm. Worst case time complexity mean algorithm which takes maximum time for execution is known as worst case time complexity. So by using big O notations, we can calculate maximum amount of time taken by an algorithm for execution. This is known as big O notation. Main use is to calculate worst case time complexity. This is definition of big O notation. Let f of n comma g of n be two non-negative functions. Non-negative is nothing but positive functions. Let f of n, that is function f of n and function g of n, these both are two non-negative functions. Then f of n is equal to O into g of n. Here I took O because big O notation is denoted by capital O symbol. So I took here f of n equal to O into g of n. If there exist two positive constants, that is c and n naught, these both are two positive constants, such that f of n less than or equal to c into g of n for every n greater than n naught. Meaning of this is condition f of n equal to O into g of n is satisfied if f of n less than or equal to c into g of n for every n greater than n naught. Second, I will explain this definition. Let f of n comma g of n be two non-negative functions. Then f of n is equal to O into g of n if there exist two positive constants, that is c and n naught, such that f of n less than or equal to c into g of n for every n greater than n naught. This is graphical representation of big O notations. This is graph in which x-axis represents number of elements, that is denoted by small n symbol, and y-axis represents time. It is denoted by small t symbol. From center there are two lines passing. First line is c into g of n, and whereas second line is f of n. C into g of n should be in upper position because I already explained big O notation is mainly used to represent upper bound of an algorithm. So c into g of n should be in upper position, and whereas f of n should be below c into g of n, that is in lower position. And point at which these two lines meet is known as n naught, where n is greater than n naught. This is an example of big O notation. Before that, you need to see this definition. From this definition, let f of n comma g of n be two non-negative functions. So at first we need to take two non-negative functions. I took f of n and g of n. These two are functions. The value of f of n is 3n plus 2, and whereas value of g of n is n. So in order to satisfy this condition, that is f of n is equal to O into g of n, in order to prove this condition, we need to satisfy this condition. In order to prove f of n is equal to O into g of n, we need to satisfy condition, that is f of n less than or equal to c into g of n for every n greater than n naught. We need to substitute f of n, value of f of n and value of g of n in this. F of n less than or equal to c into g of n, where f of n is 3n plus 2. So 3n plus 2 less than or equal to c into, and value of g of n is n. So I substituted this f of n comma g of n values in this condition. So 3n plus 2 less than or equal to c into n after substituting these values. Now we need to substitute constant c with any number. Let us take c equal to 4 because 3 plus 2 is 5. So we need to take any nearby number. So I took c equal to 4. Now I am substituting this c value in this. So 3n plus 2 less than or equal to c is 4. So 4 into n. Now we need to substitute n with any number. Here n is nothing but n naught. We need to substitute n naught with any number. We need to start from number 1. So I took n naught equal to 1. And we need to substitute this value until our condition gets satisfied. We need to keep incrementing values until our condition gets satisfied. I will substitute in this so you can clearly understand. Here 3, I took n naught as 1. So 3 into 1 plus 2 less than or equal to 4 into value of n is 1. So 1. 3 1 are 3 plus 2, that is 3 plus 2 5. 5 less than or equal to 4 into 1, that is 4. This condition is false because 5 is not less than or equal to 4. 5 is greater than 4. So this condition is not satisfied. If condition is not satisfied, we need to increment value. That is, I took n naught as 2 because 1 is not satisfied. So I incremented value. Now I took n naught as 2 and again I need to substitute this 2 in this. That is 3n. That is 3 into 2 plus 2 less than or equal to 4 into value of n is 2. That is 3 2 is 6. 6 plus 2 less than or equal to 8. That is 8 less than or equal to 8. This condition is satisfied because 8 is equal to 8. If condition is satisfied, our n naught value is found. This is condition of f of n less than or equal to c into g of n for every n greater than n naught. So here value of n naught is 2 because our condition is satisfied at number 2. So value of n naught is 2. This is an example of big O notation. Next I will explain big omega notation. If you understand this big O notation, remaining all these notations are very easy to understand because all are same as big O notation, only some small changes. Now let me explain big omega notation. Big omega notation is mainly used to represent lower bound of an algorithm runtime, whereas big O notation is used to represent upper bound of an algorithm. But big omega notation is used to represent lower bound of an algorithm, and by using big omega notation we can calculate best case time complexity of an algorithm. Best case time complexity means minimum amount of time that an algorithm requires for execution is known as best case time complexity, and by using big omega notation we can calculate minimum amount of time that an algorithm requires for execution, whereas big O notation is used to calculate worst case time complexity, but big omega notation is used to calculate best case time complexity. This is definition of big omega notation. Let f of n and g of n be two non-negative functions, then f of n equal to omega of g of n. Here I took omega because this is big omega notation. If there exist two positive constants c and n naught such that f of n is greater than or equal to c into g of n for every n greater than n naught. This definition is same as big O notation, only difference is that here in place of O we used omega and in place of less than or equal to we used greater than or equal to. Only these two difference. Here f of n is greater than or equal to c into g of n because here we are calculating best case time complexity, because big omega notation is used to calculate best case time complexity. So f of n is greater than or equal to c into g of n for every n greater than n naught. This is graphical representation of big omega notation. Here I took graph in which x axis represents number of elements and y axis represent time, and there are two lines passing from center. First line is f of n and whereas second line is c into g of n. Here c into g of n represent lower direction because big omega notation is mainly used to represent lower bound of an algorithm. So c into g of n is lower to f of n, whereas in big O notation I took c into g of n upward because it is used to represent upper bound, whereas in big omega notation it represents lower bound. So I took c into g of n lower to f of n, and point at which these two lines meet is known as n naught, where n is greater than n naught. And this is an example of big omega notation. Here I took two functions, that is f of n and g of n. Value of f of n is 3n plus 2 and value of g of n is n, same as before example. And here we need to prove that f of n equal to omega of g of n. In order to prove this we need to satisfy this condition, that is f of n is greater than or equal to c into g of n. We need to substitute c with any value. I took c value as 1. So 3n plus 2 greater than or equal to value of c is 1 into n. Now we need to substitute n with any number. We need to start from number 1. So n is nothing but n naught. Value of n naught is 1. We need to substitute this n naught value in this. that is 3 into value of n is 1 plus 2 greater than or equal to 1 into value of n is 1, that is 3 plus 2 5 greater than or equal to 1. This condition is satisfied because 5 is greater than 1. So if this condition is satisfied, we can stop here and value of n naught is 1. So f of n is greater than or equal to c into g of n for every n greater than value of n naught is 1. So n greater than 1. This is example of big omega notation. Third one is theta notation. Theta notation is mainly used to represent average bound of an algorithm, and by using theta notation we can calculate average case time complexity. Average case time complexity mean average amount of time that an algorithm requires for execution is known as average case time complexity. By using theta notation we can calculate average case time complexity of an algorithm. This is definition of theta notation. Let f of n comma g of n be two non-negative functions, then f of n equal to theta of g of n. If there exist three positive constants, they are c1, c2 and n naught, such that c1 into g of n less than or equal to f of n less than or equal to c2 into g of n for every n greater than n naught. This is definition of theta notation. Whereas in big O and big omega notations there are only two constants, that is c and n naught, but whereas in theta notation there are three positive constants, they are c1, c2 and n naught. This is graphical representation of theta notation, where there are three lines passing from center, where c1 into g of n less than or equal to f of n, that is lower bound, and whereas if you close this, f of n less than or equal to c2 into g of n, which is an upper bound, and where f of n is placed in between this. This is graphical representation. Now I will explain theta notation with an example. This is an example of theta notation, same example which we have calculated before. Let f of n equal to 3n plus 2 and g of n equal to n, and we need to prove that f of n equal to theta of g of n. In order to prove this, we need to satisfy this condition, that is c1 into g of n less than or equal to f of n less than or equal to c2 into g of n. We already calculated before. In big O notation we took value of c is 4, so value of c2 is 4, and whereas in big omega notation value of c is 1, so c1 is 1, and we need to substitute this value of c1 and c2 in this. Value of c1 is 1 into n less than or equal to 3n plus 2 less than or equal to 4 into n. Now we need to substitute value of n with any number. N is nothing but n naught. We need to start from number 1. So substitute value of n with number 1. 1 into 1 less than or equal to 3 into value of n is 1. 1 plus 2 less than or equal to 4 into 1. So 1 less than 5 less than 4. Here 1 less than or equal to 5 less than or equal to 4. 1 less than or equal to 5. This condition is true. But 5 less than or equal to 4, this condition is false because 5 is greater than 4. So again we need to substitute n by incrementing value. So let n naught equal to 2, and we need to substitute 2 in this. 1 into 2 less than or equal to 3 into 2 plus 2 less than or equal to 4 into 2, that is 2 less than or equal to 8 less than or equal to 8. This condition is satisfied because 2 is less than 8 and 8 is equal to 8. This condition is satisfied. So c1 into g of n less than or equal to f of n less than or equal to c2 into g of n for every n greater than 2. This is example of theta notation. Next, little o notation. There is no example and graphical representation of little o notation. There is only definition. Definition is, let f of n comma g of n be two non-negative functions, then f of n equal to small o of g of n, because it is little o notation, such that limit n tends to infinity f of n by g of n equal to 0. This is little o notation. And next, fifth one is little omega notation. Definition is same as little o notation. Difference is that here limit n tends to infinity, g of n by f of n equal to 0. Next topic is frequency count method. We also call this frequency count method as step count method. The use of this frequency count method is to calculate time complexity of an algorithm. In order to calculate time complexity of an algorithm, we use frequency count method or step count method. So this frequency count method specifies number of times a statement is to be executed. There are some rules which we need to follow in order to calculate frequency count of an algorithm. First one is, for comments and declarations, step count is 0. Comments and declarations are optional, they are not mandatory. So step count is 0. And for return and assignment statements, step count is 1. For example, x equal to 10. This is assignment statement. For this, step count is 1. For example, return x. For this, step count is 1. So for return and assignment statements, step count is 1. Third rule is, ignore lower order exponents when higher order exponents are present. If you consider this example, this is time complexity. In this, we need to ignore lower order exponents when higher order exponents are present. Here higher order exponent is x to the power of 4 because power is 4, so it is higher. At z square, here power is 2, so exponent is 2. Here exponent is y cube, exponent is 3, whereas here 2x to the power of 4, exponent is 4. So we need to ignore all these lower order exponents and when higher order exponent is present. So we need to consider only x to the power of 4 and ignore constants. Here 2x to the power of 4 where 2 is constant, here 3y cube where 3 is constant. We need to ignore all those constants. So here degree is O of n to the power of 4 because here exponent, highest exponent is 4. So degree is O of n to the power of 4. This is an example. In this example, we will calculate time complexity by using frequency count method. This is an algorithm. Sum of a comma n open bracket s equal to 0 for of I equal to 0, I less than n, I plus plus. In this statement is s equal to s plus a of I, and at last we are returning s. This is small algorithm. Sum a comma n where a is array. So we need to take some array of elements. So I am taking array, that is 2, 4, 6, 8 and 10. This is array of elements. Total there are 1, 2, 3, 4, 5. Total there are 5 elements. So n is, value of n is 5. Now I am calculating frequency count for each statement. S equal to 0, I already said. For assignment statements, step count is 1. So for this, step count is 1. Next statement is for loop. For loop, that is I equal to 0, I less than n and I plus plus. This is for loop. For this we need to check frequency count. This is main condition, that is I less than n where n is 5. We need to keep on checking this condition until this condition, that is I less than n, is satisfied. For example, here I am taking I equal to 0. At first we need to take element 0, that is 0 less than 5. This condition is satisfied. Next I am taking I as 1. 1 less than 5, this condition is satisfied. Next 2 less than 5, this condition is satisfied. Next 3 less than 5, this condition is satisfied. Next 4 less than 5, this condition also satisfied. At last 5 less than 5, this condition is not satisfied because 5 is equal to 5, so this condition is not satisfied. How many number of times we perform checking? That is 1, 2, 3, 4, 5, 6. 6 times we performed checking the condition. So here n value is 5. We performed checking 6 times. So for this frequency count is n plus 1. 5 plus 1, that is 6. So for this particular statement, frequency count is n plus 1. That is 5 plus 1 equal to 6. So here I written n plus 1. Inside for loop there is statement. Here for loop is repeating n number of times. So statement inside this for loop also repeat n number of times. So here frequency count is n. And at last return statement. For return statements, here we already saw. For return statements and assignment statements, step count is 1. So this is return statement. For this, step count is 1. Now we will add all this. That is 1 plus n plus 1 plus n plus 1. 1 plus n plus 1 plus n plus 1. So total time complexity is 1, 2, 3. n plus n, 2n. 2n plus 3. Here higher order exponent is n to the power of 1, that is nothing but n. So degree is O of n. This is how we calculate time complexity. Next we will calculate space complexity for this algorithm. First I am checking how many alphabets are present in this algorithm. That is 1, that is A, N, S, and I. Array contains n number of elements. So here in array there can be n number of elements. So here I took a as n, value of a as n. Similarly n equal to 5. For equal to statement step count is 1. So n is 1 and s is 1 and at last I, value of I is 1. Total n plus 1 plus 1 plus 1, that is n plus 3. Here higher order exponent is n to the power of 1. N to the power of 1 is nothing but n. So here degree is O of n. Space complexity is O of n. Both space complexity and time complexity are same for this algorithm. This is another example. Here we are calculating frequency count for square matrix. We all know square matrix. Square matrix is nothing but number of rows is equal to number of columns, that is n cross n, where n is rows and n is columns. So size of matrix is n cross n, no, n square. So algorithm, add a comma b, where a and b are two matrices and where n denotes size of matrix. This is statement inside this. For I equal to 0, I less than n, I plus plus. Inside this there are two statements, that is for of j equal to 0, j less than n and j plus plus, and at last C matrix equal to A matrix plus B matrix. This is simple algorithm. We already saw in before example. For loop frequency is n plus 1. We already saw in this example. For this particular condition frequency count is n plus 1. Here also there is same condition, that is I less than n. So frequency count is n plus 1. Here loop is repeating n number of times. So statements inside n loop also repeat n number of times. Here also loop is repeating n number of times. So statements which is inside this for loop also repeat n number of times. So value is n and n, because there are two statements. For this value is n and for this statement also value is n. And here there is another condition. This is also for loop. For loop with this condition j less than n, frequency count is into n plus 1. Same this condition also repeated here. So here also n into n plus 1. This is n plus 1, that is n square plus n. Now we need to add all those values, that is f of n equal to, here I will write n plus 1 plus n square plus n plus n, that is n square plus 3n plus 1. Here highest exponent is 2, that is n square. So 2 is highest exponent. So time complexity is O of n square, degree is O of n square. This is how we calculated time complexity. Similarly we need to calculate space complexity. Total there are three matrices, that is A, B and C. A, B and C, and there are three values, that is n, I and j. N, I and j. N, I and j are assignment statements. For assignment statement is nothing but equal to statements. For example I equal to 1, j equal to 1, all these are equality statements. So here frequency count for these three is 1, n is 1, j is 1 and I is 1. And A, B, C are square matrices. Square matrices contains n number of rows and n number of columns, that is n into n, that is n square. So frequency count for A is n square, B is n square and C is n square, that is total 3n square plus 3. Here highest degree is 2. So space complexity for this is O of n square. Next topic is divide and conquer strategy. What is meaning of strategy? Meaning of strategy is nothing but it is an approach or design to solve a particular problem is known as strategy. For example, if there is a problem in divide and conquer strategy, we will break down this problem into multiple sub problems. For example, this is large problem. I am breaking this large problem into multiple small problems P3, P4 and Pn, and we need to find solution to this each sub problem. This is solution 1, solution 2, solution 3, solution 4, so on, solution n. And at last we need to combine all these solutions of sub problems into single solution. This is known as divide and conquer strategy. In divide and conquer strategy, we divide single large problem. This is single large problem into multiple small sub problems. This large problem is divided into smaller sub problems, and then find solution to each subproblem, and then we are finding solution to each subproblem, and at last we need to combine all these solutions to get solution to main problem. This is known as divide and conquer strategy. Now I will write algorithm for this divide and conquer strategy. Divide and conquer strategy of problem. If problem is small, then we can write solution directly. Meaning of this is, if problem is small, then we can write solution of this problem directly. Else, if problem is large, then divide problem into multiple subproblems, that is P1, P2, P3, so on, Pn. Apply divide and conquer strategy to P1, subproblem P1, divide and conquer strategy to subproblem P2, so on, divide and conquer strategy of Pn. And similarly after that, after finding solution to these subproblems, we need to combine this. We need to combine all these subproblems. We need to combine all the solutions of these subproblems. Combine divide and conquer strategy of P1, that is subproblem P1, P2, so on of Pn. Here close this, and at last close this. This is algorithm for divide and conquer strategy. It is also known as general method. All these are the applications of divide and conquer strategy. First one is binary search, second one is finding maximum and minimum, third one is merge sort, fourth one is quick sort, and at last fifth one is Strassens matrix multiplication. All these are the applications. Now I will explain what is merge sort. What is meaning of sorting? Sorting is nothing but it is a process of arranging elements either ascending order or descending order is known as sorting. Arranging elements either from small to big or big to small is known as sorting. Merge sort is one of the applications of divide and conquer strategy. So here first point is merge sort is based on divide and conquer technique. This is first point. And its worst case complexity, average case complexity and best case complexity is O of n log n. This is definition of merge sort. Merge sort divides the array of elements into two equal halves and then combine them in sorted manner. I will provide one example so that you can clearly understand what is merge sort. For example, here I took array of elements. Total it contains 8 elements. This array contains 8 elements. 1, 2, 3, 4, 5, 6, 7, 8. First element is known as lower element and second element is known as higher element. Now we need to sort this array by using merge sort. Formula of merge sort is lower plus higher by 2. In this there is 8 elements, so we need to divide this into two equal halves. That is 4 elements in one side and 4 elements in another side. This is middle. Now I am dividing this into two equal halves. 4 elements in one side, that is 15, 34, 28 and 11, and 15 elements in another side, that is 36, 20, 43 and 45. Now again we need to divide these 4 elements into two equal halves, that is 2 elements in one side and 2 elements in another side, that is 15, 34 and 28, 11. And similarly we need to divide this into two equal halves, 4 elements to one side and to another side, 36, 20 and 43, 45. And again we need to divide this two elements into equal half, that is one element in one side and one element in another side, 15, 34, 28, 11 and 36, 20 and at last 43 and 45. After dividing each and every element, we need to combine this in sorted manner. Now I am combining this in sorted manner, that is 15 is first and 34 is second, because 15 is smaller and 34 is larger. And similarly this one 11 and 28, because 11 is smaller and 28 is larger. Similarly do this 20, 36 and similarly this one 43 and 45. I arranged this in sorted manner. Similarly we need to sort this. First 11 is smaller, 11, after that 15, after the smaller element is 28 and after that 34. You can do this, do same for this, 20, 36, 43 and 45. I am arranging elements in sorted manner, and at last we need to sort these 4 elements, that is 11, after 11 15, after 15 which is smaller 20, after that 28, after that 34, after that 36, and after that 43, and after that 45. This is final output. This is how we will do sorting by using merge sort. I hope you have understood. Now I will write algorithm for merge sort of lower comma higher element. Lower element is nothing but it is first element and higher element is second element. If of lower element is less than higher element, meaning of this is array contains more than one element. For example, if this array contains 2 elements, first one act as lower element and second one act as higher element. So meaning of this is arrays contain more than one element, so that we can perform merge sort. So we can perform merge sort if this condition is true. How we will perform? That is, we need to find middle element. How we will find middle element? We will find by using this formula, lower plus higher by 2. For example, this is an array, it contains 5 elements from 1 to 5, and formula is lower plus higher by 2, that is 1 plus 5 by 2. Lower element is 1 and higher element is 5, that is 6 by 2, that is 2 1 are 2 3 are 6, value is 3 here. So we need to take third element as middle element. This is lower element and this is higher element. After that, merge sort of lower element comma middle. That means we need to divide this 1 2 3 and 4 5. First part contains lower elements and as well as middle element, and similarly another part contains merge sort of middle element plus 1 comma higher element. After performing merge sort, we need to combine this both. So value is, so here we need to write merge of lower comma middle element comma higher. At last we need to combine this both. After that we need to close this. This is algorithm of merge sort. It is very easy. Once if you practice, you will get. Time complexity of this is T of n by 2 and time complexity of this is T of n by 2 and time complexity of this is n. This is n number of elements in array. Time complexity of this is T of n by 2, because here we are dividing this n into half. So here I took n by 2. Time complexity of n by 2, and here merge sort of this is T of n by 2, and at last if we combine this both, this time complexity is n. So here T of n by 2 plus T of n by 2 plus n, that is 2T of n by 2 plus n. This is time complexity of merge sort. Next topic is binary search algorithm. In linear search, in order to find particular element, we need to search each and every element line by line. So it is time taking process. So in order to overcome the limitation of linear search, new searching technique is developed, that is binary search, in order to save time. For example, this is an array of elements. It contains total 6 elements. I want to find element 6. So in linear search, it will search each and every element. First it go to first element. 6 is not present in first. So again it will go to second. 6 is not present in second. Again it will go to third, it will go to fourth, and at last it will go to sixth. Therefore we got sixth element here. In linear search, it will search each and every element in order to find particular element. It is time taking process. So in order to overcome the problem of linear search, binary search algorithm was created in order to save time. Binary search is fast searching algorithm with runtime complexity of O of log n. This is runtime complexity of binary search, and this binary search is based on divide and conquer strategy. In divide and conquer strategy, we will divide problem into sub problems, and then we will solve sub problems, and then at last we will combine these solutions of sub problem into single solution. This is known as divide and conquer strategy. This binary search follows divide and conquer strategy. In binary search technique, we search an element in sorted array. Sorted array is nothing but elements which are arranged from small to big is known as sorted array. This is sorted array. This is example of sorted array because elements are arranged from small to big, that is 1 2 3 4 5 6, and we need to find particular element in this sorted array in binary search. For example, here I want to find element 4. We search an element 4 in sorted array. This is example of binary search. I will give one example how to find element in binary search so that you can clearly understand. This is an example of binary search. In this they given list of sorted array. Here they are given total 1 2 3 4 5 6 7. Here there are total 7 elements. In this we need to find element 71, and this binary search is applicable only for sorted array. In order to perform binary search, elements should be arranged from small to big. So here elements are from small to big, so we can perform binary search. At first you need to write elements 11 24 55 60 71 77 and 80. Total there are 1 2 3 4 5 6 7. Total there are 7 elements in the array. In this you need to find middle element. Formula to find middle element is lower element plus higher element by 2. This is formula. Lower element is nothing but first element and higher element is last element in the array. First element in the array is lower element and last element in the array is higher element. Formula is lower element, that is 1, not 11, 1. 1 plus higher element, that is 7, not 80, 7 by 2, that is 8 by 2. 2 1 ja, 2 4 ja 8, that is 4. So mid element is, value of mid is 4, that is 1 2 3 4. Middle element is 60. Here 71 is the value which we need to find. If value is equal to mid, then our result is true. We can close. That is, we got our result. Here 71 is the value which we need to find. But here mid value is 60. 71 is not equal to 60. 71 is not equal to 60. 71 is greater than 60. So if value is greater than mid, then convert this mid into lower element, because 71 is greater than 60. Elements are already arranged in sorted format. So 60 is smaller element now. So we need to convert it into lower element. Convert this 60 as lower element. Again we need to find mid. Value of mid is lower element plus higher element by 2. Lower element is 4 plus higher element is 7 by 2. That is 11 by 2. That is 2 1 ja, to 5 point. Don't consider elements which is after point, that is 5. So mid element is 5. Value which we need to find is 71. If value and mid element is 71. Here value is equal to mid. So we found that element. So we found element 71. If value is equal to mid, then we can stop. We got our result. Here mid value is 71. This is how we can search particular element by using binary search. This is one more example. Here I need to find element 24. I need to find 24. So you need to apply formula, that is mid. Formula of mid is lower element plus higher element by 2. Lower element is first element in the array and higher element is last element in the array. That is 1 plus 7 by 2. That is 8 by 2. 2 1 ja, 2 4 ja 8. 1 2 3 4. Value of mid is 4. So here mid value is 4. Value is not equal to mid. Here value which we need to find is 24. But here mid value we got is 60. 60 is not equal to 24. 24 is less than 60. So in that case, if value is less than mid, then change mid element to higher element, because our element is present in between this. Our element is present in between this 11 and 60. So I changed this mid element as higher element. We should not change this mid element into lower element, because if we change this mid element into lower element, then our element will be present in between this. So here I changed mid element as higher element. You need to remember these two things. If value which we need to find is less than mid, then change mid to high. And if value is greater than mid, then change mid to low. These two things you need to remember. Here value is less than mid, that is 24 is less than 60. So we need to change mid to higher. Again we need to find mid. Formula of mid is lower element plus higher element by 2, that is 1 plus 4 by 2, that is 5 by 2. 2 1 ja, 2 2 ja 4, 0.5. Don't consider element which is after point, so your value is 2. This is mid. Value which we need to find is 24. Mid value is 24. Therefore we got our result. We can stop this. If value is equal to mid, then
we successfully searched that element. For example, consider same example, but here I need to find 23. 23 is not present in this array. Here there is 11, 24, 55, but there is no 23 element. In that situation, it will become 23. This is another example. Then in that situation, you need to convert this mid element as higher element. If lower element and higher element comes side by side, then therefore element is not found. We cannot find that element, and in that situation you can write therefore element is not present. This is another example. This is algorithm for binary search. Step 1. In step 1 we need to find lower element, that is first element in an array, and I am taking this lower element as L, low equal to L, and similarly highest element, that is last element in an array. I am denoting this high as H. After finding lower element and higher element, next we need to apply mid formula. Formula of mid is low plus high by 2. This is formula. After this you need to go to step 2. Go to step 2. Step 2 is if value is equal to mid, then return mid. We need to return mid. Our result is found. Print element found. Element found at mid. This is value which we need to print. If value is equal to mid, then print element found. Then at last go to step 5. Step 5 is stop. Else, if value is not equal to mid, then there is two chances. That is step 3. That is if value is greater than mid, then change mid to low. As I already said in before example, if value is greater than mid, then change mid to low, and again go to, after changing mid to low, again you need to perform this, again you need to apply this formula. So go to step 1. Else, if step 4, else in step 4, if value is less than mid, then change mid to high. After changing mid to high, again you need to calculate mid value. So again go to step 1, and at last step 5. Step 5 is stop. Here I said now step 5 stop. Else if we do not find that value, then here otherwise, when condition fails, that is we cannot find any element. If condition fails, print element not found. Print element not found and go to step 5, that is stop.
Next topic is quicksort algorithm with an example. When compared to remaining sorting techniques, quicksort is one of the best sorting technique. It is based on the partitioning of array into smaller arrays. In quicksort, for example, there are elements in an array. We will break this array into smaller arrays and perform sorting. It is based on the principle of divide and conquer strategy. Quicksort follows divide and conquer strategy. In divide and conquer strategy, we will break large problem into smaller problems. For example, this is large problem. We will break this large problem into smaller sub problems, and we will find solution to these sub problems, and at last we will combine all these solutions into single solution. This is known as divide and conquer strategy, whereas quicksort follows divide and conquer strategy. Average and worst case complexity of quicksort is O of n log n. These are the steps which we need to follow in quicksort. In quicksort, at first we need to find pivot element. This pivot element divides an array into two halves. One is left half and one is right half. And in step 2, we need to perform quicksort on left half, and at last we need to perform quicksort on right half. This is how we perform sorting by using quicksort. I less than p less than j. That means I is left side elements, whereas j is right side elements, where pivot is placed at center. I will give an example so that you can clearly understand how to perform quicksort. This is an example which we need to solve by using quicksort. Sort an array. We need to arrange these elements from ascending order to descending order, that is from small to big, by using quicksort. You need to remember one thing. In quicksort, at first you need to select pivot element such that all left side elements of pivot should be smaller and all right side elements should be larger than pivot. This is an example: 10, 80, 30, 90, 40, 50 and 60. Total there are 7 elements. There is no proper rule that you need to select only this element as pivot element. So you can select any element as pivot element. You can select first element as pivot or middle element, or you can also select last element as pivot element. In this, I am selecting last element as pivot element, and you need to select first element as I, that is smaller element, and last element as j. first element must be I and last element must be j. This is rule which we need to follow. I must be smaller than pivot and j must be larger than pivot. Now we need to perform sorting based on this rule. That here I took pivot as 60. What is the rule? I less than p. What is I? I is 10. 10 is less than 60. This condition is true because 10 is less than 60. So if condition is true, that is if I is less than p, then move I one position forward. And again we need to compare I and p. Here now I is 80. 80 less than 60. Here condition is false because I is not less than p. So here I is, here condition is false. If condition is false, then we need to swap I element and j element. We need to interchange I and j elements. That is 10. In place of 80, we need to write 50, 30, 90, 40, and in place of 50, we need to write 80. And here 60 is pivot element. Here I is 50 and j is 80 because we interchanged elements. Whenever we perform swapping, swapping is nothing but interchanging elements. Whenever we perform swapping, we need to move I one position forward and j one position backward. Whenever we perform swapping, we need to move I one position forward and j one position backward. This is condition I less than p. If this condition is true, then move I one position forward. If I element is less than p element, in this 10 is less than 60. So what we did is we moved I one position forward. If condition is false, in second situation condition is false. If condition is false, then swap I and j elements, and after interchanging I and j elements, we need to move I one position forward and move j one position backward. Here I moved one position forward now. After moving I one position forward, our I element is 30 and j element is, because I moved j one position backward, so j element is 40. Again we need to compare, that is I less than p. What is I? 30. 30 less than 60. This condition is true. Whenever condition is true, we need to move I one position forward. Now again we need to compare, that is 90 less than 60. This condition is false because 90 is not less than 60. Whenever condition is false, then interchange I and j elements, that is 10, 50, 30. Now I element is 40 and j element is 90, 80 and 60. 60 is pivot. Whenever we perform swapping, move I one position forward and move j one position backward. It is 10, 50, 30. I moved j one position backward, so j is 40 and I moved I one position forward, so 90 act as I element, 80 and 60. 60 is pivot. Whenever actually I should be first and after I there should be j, but in this j came first and after j there is I. So whenever I crosses j and j crosses I, in that situation we need to stop performing swapping and then place pivot element in between j and I. That is, we need to place pivot in between this 40 and 90, j and I. After that 10, 50, 30, 40, 60. 60 is pivot element, 90 and 80. What is condition? I less than p less than j. That is, all left side elements of pivot should be smaller than pivot and right side elements must be larger than pivot. This condition is satisfied because all I elements are less than pivot. See 10 is less than pivot, that is 60. 50 is less than 60, 30 is less than 60, 40 is less than 60. Similarly right side elements, 90 is greater than 60 and 80 is greater than 60. After that
Again we need to perform swapping. So 10, 50, 30, 40. For these elements we need to perform swapping, and for these two we need to perform swapping. I took last element as pivot element and first element as I and last element as j. What is condition? That is I less than p less than j. This is condition. Again we need to compare. That is I less than p. That is 10 less than what is pivot element? That is 40. 10 is less than 40. This condition is true. Whenever condition is true, you need to remember these two things. Whenever condition is true, move I one position forward. So I am moving I one position forward, that is from 10 to 50. Now 50 is I element. Again we need to compare 50 less than 40. Here I is not less than p. Whenever condition is false, then swap I and j elements. That is we need to interchange I element and j element. That is 10, 30. Now 30 becomes I element and 50 becomes j element, and this is 40. And after performing swapping, then move I one position forward. That is we need to move I one position forward and we need to move j one position backward. So 10, 30, I moved j one position backward, so 30 act as j and 50 act as I element because I moved I one position forward, and 40 is pivot element. Whenever I crosses j and j crosses I, whenever j comes first, in that situation we need to stop performing swapping and we need to place pivot element in between j and I. So now answer is 10, 30, this we need to place pivot element in between 30 and 50. So 40, 50. See, all are in sorted format. That is all these elements are from small to big. And similarly we need to perform swapping for these two also. That is 90 and 80. Here I took 90 as I and 80 as pivot element. Here there is no j, so directly we can perform swapping. Directly I am interchanging elements 80 and 90. So after performing swapping, we got all elements in sorted format. We arranged all these elements in sorted format, that is 10, 30, 40, 50, and this pivot is, we arranged this left side elements in sorted format, and pivot element is 60, and after 60, 80 and 90. 80 and 90. All these elements are arranged in sorted format. This is how quicksort will work. We need to remember these two conditions. That is, if I less than p, if condition is true, then move I one position forward, and if condition is false, then we need to swap, we need to interchange I and j elements, and after interchanging I and j elements, we need to move I one position forward and then we need to move j one position backward. Based on these two conditions, we can perform swapping. This is pseudocode for quicksort. We are performing quicksort on array of elements. That elements contain lower element and as well as higher element. If lower element is less than higher element, then at first we need to find pivot. That pivot divides an array into two parts. That is, one is left half and one is right half. This pivot partitions array into two halves. One is lower half and one is higher half. If you see this example, in this example I found pivot, that is 60. This 60 divides an array into two parts. One is left half and one is right half. We need to perform quicksort on this left half and we need to perform quicksort on this right half. This is meaning of this. We need to perform quicksort on left half. Left half contain lower elements, that is which is less than pivot, and right half contains higher elements which are greater than pivot. So here I written pivot plus 1.
Next topic is Strassens matrix multiplication. Strassens matrix is one of the applications of divide and conquer strategy. So first point is Strassens matrix it follows divide and conquer strategy. This is first point. We can perform Strassens matrix multiplication only on square matrix. Square matrix is nothing but matrix in which number of rows is equal to number of columns is known as square matrix. I will give one example so that you can clearly understand. I took two matrices. One is matrix A and second one is matrix B. Inside matrix A, I written A11, A12, A21 and A22. This is square matrix because it contains two rows and two columns. If number of rows is equal to number of columns, it is known as square matrix. Similarly, inside B matrix, I written B11, B12, B21 and B22. Meaning of this is first row first column, first row second column, second row first column and second row second column. This both are 2 cross 2 matrix. And another matrix is C. By applying Strassens matrix multiplication on these two matrices, we will get value of C. We can find C matrix. So inside C matrix, I written C11, C12, C21 and C22. We need to perform Strassens matrix multiplication on this matrix A and matrix. So we need to follow some formulas for this. Here write P, Q, R, S, C, U, V. Formula of P is A11 plus A22 into B11 plus B22. This is formula of P. We need to add diagonal elements, that is A11 plus A22, and similarly in B, B11 plus B22. This is formula of P. We need to add diagonal elements A11 plus A22 into B11 plus B22. This is formula of P. Next we need to write formula of Q. To write formulas for this, you need to remember Bob. B-A-A-B. You need to remember this. B-A-A-B. That is Bob. Take here B11, A11, A22. Write 1, 1, 1, 1, 2, 2 and 2, 2. Write this here. B11, A11, A22 and B22. Open brackets here. And you need to remember this. First row, first column. First row, second column. Second row, first column. And second row, second column. Two arrows passing towards right side. And similarly, it is passing to top and this arrow is passing to downwards. One arrow is upward and one arrow is downward. And similarly, here 1, 2, 3 and at last 4. So for Q, value is A21 and A22. This is first one now. So here I am writing this arrow is passing towards this direction. So here I am writing A21 plus A22. A21 plus A22. And similarly for second one, this arrow is passing downward direction for second. So here we need to write, here this is B now, so here we written A. Here it is A, so we need to write B here, this direction. So here B12, for A we took plus, for B we need to take minus. B12 minus B22, B2. And similarly for third one, this arrow is passing upward direction, that is from 21 to 11, this direction. So here it is A, so we need to write here B. B21, for B we need to take minus B11. This is formula. And for fourth one, that is for this T, for this value of T, first we need to write here B now, so we need to take A. A11, for A we need to take plus A12. So we got value of Q, R, S, T. Once again I will explain this. We need to remember this matrix, that is 1, 1, 1, 2, 2, 1 and 2, 2. For first one is passing towards right direction, and similarly top also right direction, and one is upward direction, one arrow is upward direction and another arrow is downward direction. First we need to take 1 here, 2, 3 and this is 4. So here we need to remember B-A-A-B. So here I written B11, next A11, next A22 and B22. B11 value is B here, so we need to take A. So here first one is passing towards right direction, that is from 21 to 22. So here I took A21 plus, for A we need to take plus, A21 plus A22. And similarly for value of R, here A11, so we need to take B. Second one is B12 and for B we need to take minus B22. And similarly S value is here A22, so we need to take B. This is passing towards top direction, so from here to here, from 21 to 11. So B21, for B we need to take minus B21 minus B11. And at last value of T, at T is B22. So here this is passing towards right directions from 1, 1 to 1, 2. So here I took A11, for A we need to take plus A12. Next we need to find value of U and V. B11 plus B12. You need to write here. Write matrix here. B11, B12, B21 and B22. This is matrix B which I have written here. Here take here plus and take here plus. For B value is plus. So for A we need to take value as minus. First one is here for this. We need to take value of 3 here. We need to follow this upward direction for this U. So here write here B is plus. So for A we need to write minus. So here A21 minus A11. We need to follow these 3 for U value. And similarly for V value, here B is placed. So for A we need to write minus. We need to follow number 2 here. So here A12 minus passing towards downward direction, that is from 1 to 2 2. So A12 minus A22. So now we got all these values, that is from P to V. We got all these values. As I said before, by multiplying these two matrices, we will get value of C matrix. So here we need to find C matrix, that is C11, C12, C21 and C22. We need to find all these values in order to get matrix C. Formula of C11 is P S T V. How I remembered this is like I remembered like PS stands for Photoshop and TV stands for television. This is how I remembered this formula. Here take plus and middle minus. This is formula of C11. And similarly formula of C12. How I remembered this formula? I remember rat, R-A-T, rat. We know rat, no? So I remember this as rat, R-T. Instead of A we need to write plus here. This is how I remember this formula. And next C21. I remember this formula as queens, Q and S. Here we need to take plus. Similarly last formula, that is for C22. Write P as it is like this, P, which is written in C11 plus here S, opposite of S is R, diagonal element of this S is R. So here take R, keep minus as it is, and T, value of T is I am taking diagonal element, opposite of T is Q. So here I took Q and at last U. This is formula. If you find this, you will get matrix C. You need to remember these formulas so that you can solve any problem. In exam you will get various kinds of matrix problems of this Strassens matrix multiplication. So you need to remember these formulas. Now I will provide one example so that you can clearly understand how to solve this problem. This is one of the example. You will get a question like this in exam. Find Strassens matrix multiplication of two matrices A and B. Here they given two matrices, one is A and one is B, and we need to perform Strassens matrix multiplication. That is, we need to find C, value of C. So let C equal to C11, C12, C21 and C22. This one we need to find. So by using this formula we need to find this matrix. Here A11 is 1. A11 equal to 1 and A12 equal to 2, A21 equal to 3 and A22 equal to 4. And similarly B11 equal to 2, B12 equal to 2, B21 equal to 3, B22 equal to 1. These are the values. First we need to find value of P. P equal to A11. What is value of A11? That is 1. 1 plus value of A22. That is 4. 1 plus 4 into B11. Value of B11 is 2. 2 plus value of B22 is 1. That is 5 into 3. That is value of P is 15. Similarly, now we need to find value of Q. Similarly, we need to find all these values. That is from P to V. We need to find these values P, Q, R, S, T, U, V. We need to find all these values. I found all these values by using this formula. I found all these values, that is value of P is 15, value of Q is 14, R is 1, S is 1, T is 3 and U is 8 and V is minus 8. After that we need to find matrix C, that is C11, C12, C21 and C22. This is formula PSTV. Value of P is 15 plus value of S is 1 minus value of T is 3 plus value of V is minus 8. So 16 minus 3 minus 8, that is 16 minus 11. So value is 5. Value of C11 is 5. And similarly we need to find C12. R plus T. What is value of R? That is 1. 1 plus value of t is 3. 1 plus t, that is 4. C12 is 4 and C21, that is q plus s. Value of q is 14 plus value of s is 1, that is 15. Value of C21 is 15, and similarly we need to find value of C21, that is p. Value of p is 15 plus r is 1 minus value of q is 14 plus value of u is 8. 15 plus 1, that is 16. 16 plus 8, that is 23. 23 minus 14, value is 9. Value of C21 is 9. This is final output. This is final value. This is how we need to solve Strassens matrix multiplication problem.
Guys, I have already explained Strassens matrix multiplication example. First learn example and then go for algorithm. If you watch this algorithm directly, you will not understand. So first watch Strassens matrix multiplication example. In linear algebra, Strassens algorithm is named after Walker-Strassen. The name itself says Strassens matrix multiplication. So it is an algorithm that is used for matrix multiplication. We use Strassens matrix multiplication because it is faster than normal matrix multiplication. So we use Strassens matrix multiplication and it is suitable for multiplying large matrices. We can perform Strassens matrix multiplication only on square matrix. Square matrix is nothing but matrix in which number of rows is equal to number of columns is known as square matrix. For example, this is square matrix because it contains 2 rows and 2 columns. So it is square matrix. It is performed only on square matrix of order of both matrix must be n cross n. For example, size of this matrix is 2 cross 2, that is 2 rows and 2 columns. Similarly, another matrix also should contain 2 rows and 2 columns. So both size of both matrices should be same in order to perform Strassens matrix multiplication. The idea of Strassens method is to reduce number of recursive calls to 7. So its total time complexity is O of n to the power of log 7 because it reduces number of recursive calls to 7. So this is time complexity of Strassens matrix multiplication. And in Strassens matrix, there are 7 multiplications, 4 additions and 4 subtractions. Now I will write algorithm for Strassens matrix multiplication. This is an algorithm. Step 1. Step 1 is start. Next step 2. Because we are starting algorithm. So I written start in step 1 and in step 2, I am performing Strassens matrix multiplication on 2 matrices, that is matrix A and matrix B. So write Strassen of matrix A comma matrix B. We can perform matrix multiplication only if length is greater than or equal to 1. So if length of matrix A equal to 1, then return A into B. That is, if length of matrix is greater than 1, then we can perform matrix multiplication. Now we are performing a matrix multiplication on matrix A and matrix B. So step 3. In step 3, we will split matrix A and matrix B. Then split matrix A into 4 parts, that is A11, A12, A21 and A22. For example, this is matrix. Matrix contains, this is 2 cross 2 matrix. It contains 2 rows and 2 columns, A11, A12, A21 and A22. I am splitting matrix A. This is matrix A. I am splitting this matrix into 4 parts. That is A11, A12, A21 and A22. This is meaning of this. Next split matrix B into 4 parts. That is B11, B12, B21 and B22. This is step 3. Next in step 4. In step 4, I took alphabets from P to V. That is P, Q, R, S, T, U and V. Now we need to apply formula for this. Formula of P is A11 plus A22 into B11 plus B22. Next formula of Q is B11, A11, B11 of A21 plus A22. This is formula of Q. Next formula of R is A11 into B12 minus B22. Next formula of S. Next A22 and B2. Formula of S is A22 of B21 minus B11. This is formula of S. And formula of T is B22 of A11 plus A12. This is formula of T. Next formula of U, that is B11 plus B12 into A21 minus A11, B21 plus B22 into A12 minus A22. Already said that Strassens matrix contains 7 multiplications, 4 additions and 4 subtractions. If you count this, you will get 7 multiplications, 4 additions and 4 subtractions. Next, step 5. If you perform matrix multiplication on matrix A and matrix B, you need to store result on matrix C. So, matrix C contains C11, C12, C21 and C22. C11 equal to P plus S minus T plus V, and whereas C12 is R plus T, C21 is Q plus S and C22 is P plus R minus Q plus U. And step 6. In step 6, you will get result of matrix C, that is C11, C12, C21 and C22. When you get result of matrix C, you can stop. Step 7 is return C, because this is result. So I am returning C, and at last step 8 is stop. This is Strassens matrix multiplication algorithm.